Alright, so this is going to be a pretty quick video. There are four types of reactions that involve either an acid or a base that will result in a gas forming. If you have any sort of metal carbonate or bicarbonate and you add it to an acid, it can make carbon dioxide along with the ionic salt and water. Basically, it's making carbonic acid that breaks down into CO2 and H2O. If you've ever mixed vinegar and baking soda together, the bubbles you see are the CO2. Hydrogen sulfide can be formed by mixing a metal sulfide with an acid. The hydrogen and the sulfur make the hydrogen sulfide gas, and then the metal and the rest of the acid, the anion component, make the metal salt. With SO2, you need to have a sulfite. So the SO3 polyatomic, it combines with the hydrogen of the acid to make sulfurous acid, and that breaks down into SO2 and H2O, and the metal and the anion of the acid will make the metallic salt. And then finally, if you have a strong base with ammonium, ammonium, remember, is not one of the weak bases. It is a little bit different. It actually has acidic properties, and when it gives away one of its protons to the base, it leaves behind ammonia and water, and then the cation of the base and the anion of the ammonium salt will make a metallic salt. So we're going to go through one example with each of these. Again, you can take as many notes as you would like, or as few notes if you would like. And these PowerPoint slides are also posted on Classroom as well. So the first one we're going to look at is with nickel 2 carbonate when it's treated with sulfuric acid. So the carbonate means we're going to make carbon dioxide once all is said and done. NiCO3 is nickel carbonate. They're +2 and -2 respectively. Sulfuric acid would be H2SO4. So the hydrogen and the carbonate ions are going to combine together to make carbonic acid, which will then break down into CO2 and H2O. We will make a compound with the metal of the carbonate compound and the anion of the acid, NiSO4. So basically we're just crossing the two on the outside go together, the two on the inside go together. The sulfates are soluble and we have water around, so that's going to make NiSO4 aqueous. CO2 and H2O are going to form. We cannot break apart the nickel carbonate. We can, however, break apart the sulfuric acid. It's a strong acid and it's aqueous. We can break apart the nickel 2 sulfate, but we can't break apart the gaseous CO2 or the liquid water. So the sulfates cancel out, leaving us with NiCO3 and 2 hydrogen ions, making Ni+2 along with CO2 and H2O. So just a little bit more practice at these net ionics. And these are the four that make the most common gases that we're going to see in our reactions. So the second one is with the strong base. Lithium hydroxide is combining with ammonium chloride. Ammonium's +1, chlorine's -1. So we get NH4Cl. We're told it's a solution, so by default it must be aqueous. Lithium hydroxide, I told you it was combined with, and I'm going ahead and telling you here that it's aqueous. I would have to give you some information to know whether it was aqueous or in solid form. The ammonium and the hydroxide come together to make ammonium hydroxide, which then readily decomposes into ammonia and water. And the lithium and chlorine come together to make lithium chloride. The +1 and -1 charges, so those cancel out. And because water is present due to the water formed between ammonium and hydroxide, that would be made as well. So the compounds that can ionize are the two reactants and the lithium chloride product. So those are going to be separated back into their ions respectively. Ammonia and water stay intact. So if we look at both sides of the equation, we see that we have lithium and chloride ions on both sides, so those are going to cancel. And we're left with the ammonium ions and the hydroxide ions making ammonia and water. So 2 more to go. This one's going to be with the sodium sulfite, the aqueous solution of sodium sulfite, and how it's mixed with acetic acid. So sodium sulfite, SO3 is -2, sodium is +1, Na2SO3. Acetic acid is from the acetate ion, it's a -1, hydrogen is +1. But to balance that equation out, we'll see that on the other side when we combine the H with the SO3 and the sodium with the acetate, we need 2 sodiums from the Na2SO3, so we're also going to need 2 acetates, and it's a 1-to-1 ratio. And then the H from the acid and the SO3 from the sulfite ion are going to make sulfurous acid, which H2SO3 will break down into SO2 and H2O. Now this time only 2 of our 3 compounds can be ionized because acetic acid is a weak acid. We can ionize the sodium sulfite. All alkali metals that are around water and compounds will be soluble. The acetic acid needs to stay together. The sodium acetate will need to ionize, but the sulfur dioxide and the water will stay together. So the sodium ions cancel, but everything else stays intact. So we have the sulfite along with the acetic acid molecules making the 2 acetate ions, sulfur dioxide, and water. And the last gas-producing reaction we're going to talk about involves forming hydrogen sulfide gas. You're told that you have crystals of potassium sulfide. Potassium is +1, sulfur is -2, so when you cross your charges you get K2S. Nitric acid, nitrate is the source of nitric acid, +1 and -1, HNO3. But when we cross K with NO3, we get that K is +1, NO3 is -1. We need 2 H's to make the hydrogen sulfide gas. So because we need 2 H's, on the reactant side, we're going to need 2 of the nitrates along with 2 of the potassiums, and H2S will be formed. Our solid and our gas cannot be ionized, but our strong acid, the nitric acid, can be, as well as the aqueous ionic compound with potassium and nitrate. So the hydrogen and the nitrate are going to split, 2 of each. Same with the potassium and the nitrate, but the H2S will stay put. So the 2 NO3s cancel, and we're left with K2S and 2 hydrogen ions making 2 potassium ions and hydrogen sulfide gas. So that is all the gas-producing reactions. I just wanted you to kind of get an overview of them so that when I come back on Tuesday we can practice these a little bit more.